Hello folks and welcome back. Root Beer here with the 2000 Pascal paper, and we're on to question number 13. Alright, this is an interesting looking question. In the expression a over b plus c over d plus e over f, each letter is replaced by a different digit from 1, 2, 3, 4, 5, and 6. What is the largest possible value of this expression? Okay. So, what can we do here? Well, it's only 6 numbers, so we could probably fiddle around and guess. That might be something worthwhile. Or maybe we could take a smaller case, maybe 1, 2, 3, 4, and ignore the e over f. That's certainly something we could try. Or maybe there's some general way to write this all out. Let's think. What might work? Well, it'd be interesting if we could get a common denominator here. Okay, so I don't know what B, D, and F are, but since they're among 1, 2, 3, 4, 5, and 6, then I could easily get a common denominator of 6 factorial. But then the question is, how do I make the expression big enough? Well, let's try exploring with 1, 2, 3, and 4. So, okay. So, we want to make A plus B over C plus D as big as possible. So B and D are both in the set 1, 2, 3, 4. So what I could do is I could say, if I try and get a common denominator, it's not really going to help. It's just going to sort of shift the fraction to the top. Yeah, I think we're just going to sort of have to eyeball this one. So, let's ask ourselves, if we just wanted to make a fraction as big as possible. So say we just want to make A over B as big as possible, what would we choose? Well, I think it's pretty clear to say we'd choose 4 over 1. Because think about it, anything else, 4 over anything else, we're just going to be dividing by too big a number. Okay? And if we were to take any other number, we'd have, this is 3, and this is 4. 4 definitely bigger than 3. And if we were to do the same thing with 2, it would at most be 2, which is definitely less than 4. So I would say 4 over 1 definitely our best bet for making things pretty large. And how about once we have 4 over 1, we are left with 3 and 2. Well, we'd have to get 3 divided by 2. Now, is there another way to see that? What if we had A over B plus C over D? Well, we could write that as AD over BD plus BC over DC. Oh, sorry, DB, BD. And then we could definitely add them. We got a common denominator that way. Is there a nice way of maximizing that sum? I don't think there is. I think it's probably just going to be guesswork that works best for us here. It's a Pascal 9, so odds are if I just eyeball it and say, oh, well, you pick the biggest number divided by the smallest number, then you pick the next biggest number divided by the smallest number, and pick the next biggest number divided by the next smallest number, then you should get the maximum. But I want to see why that's true, why there isn't some weird extra combination that works. So what does this turn out to be? This turns out to be 5.5, right? What if I were to try another combination? What if instead I were to go 4 divided by 2 plus 3 divided by 1? Well, that's 2 plus 3. Okay. So that's not going to work. That's 5. Definitely less than 5.5. So it looks like this will end up working. But why? So if I were to multiply by A and C, I would definitely get 24 on the bottom. But then I would get A squared CD plus AB C squared. And it would all go over 24 because 24 is the product of 1, 2, 3, 4. That doesn't seem to be a nice way to make this as large as possible. Okay. So, I think, honestly, I'm at wit's end here. I think that it's got to be just sort of a guess. There might be some inequality. Pen's not erasing. There we go. I think there might be some arithmetic inequality or something like that that actually solves this for you, but for the moment, it is escaping me. So I'm going to say we're going to pair up the numbers from biggest and smallest, and then next biggest, next smallest, and we're always going to have the larger number in the numerator. So I should get 6 over 1 plus 5 over 2 plus 4 over 3. Now, would I love to come back and investigate this question? I absolutely would. And I'd actually love to go see the solution from Waterloo. And if you're curious, of course, you can click one of the links in the description. It'll take you to their contest page where you can find the solutions to this contest. But it's question number 13 on a Pascal. We're not going to be using a heavy-duty inequality to solve this kind of question. Odds are what you see is what you get. It's not like a question 24 on a Fermat or something. So I think this is probably our best bet. And what does this turn out to be? 6 plus 2.5 plus 4 over 3, so 4/3. So we're going to get 9.83 repeating. And as a fraction, did they have it as fraction or as decimal in their solution? Okay, so they have it as fraction. And it'll probably be that b minus 956. But let's multiply by 6. And we've got 59, so yeah, it'll be 9 5/6. Okay. I'm still upset. There should have been sort of an approach I could do. Maybe something like this is best. So let's actually complete this little chart for a moment. So obviously we're only going to be interested when, well, not obviously we're only going to be interested when the top number is biggest, but let's take a look here. One divided by 3 and 1 divided by 4. So 4 divided by 2, 4 divided by 3. And 3 divided by 4, 2 divided by 4, and 3 divided by 2, and 2 divided by 3. So for this one, what we've done is we basically picked the biggest number out of all of them because they get smaller as you go right and down. So we pick the biggest possible number, and then that means we can't choose any of these because the 1's already spoken for. Can't choose any of these because the 4 is spoken for, and then choose the next biggest number. I think that's probably the heuristic we're supposed to use. So it would look a little something like this. 6 and 1 is the biggest of them all, then 6 over 2, then 6 over 3, 6 over 4, 6 over 5, 5 over 1, 5 over 2, 5 over 3, 5 over 4, and 5 over 6. So basically, the idea to maximize it is to choose your best possible fraction, which is going to be the one in the top left corner. And then once you choose him, well, the other fractions in the same row and column are not allowed because, for example, the 1's already used and the 6 is already used. So then we choose the next biggest fraction and cancel out its row and column, and then choose the next biggest fraction until we basically run out of numbers to use. Okay? And I guess this column also gets canceled out, so we pick this one, cancel that, and then we choose this one and cancel that. So I guess that's the idea. You just I wish it were clearer that it's that you should pick the biggest, then pick the next biggest, because I would think that maybe if you chose, maybe this pair, for some reason, it might all work out. Oh well. There doesn't have to be a clear-cut solution to everything. I mean, we got our best guess, and we have some reasoning behind it. So I would actually be very curious to see if this is incorrect for some reason. And I'd also love to go see the solution. I might go look it up in a moment. But I think I spent way too much time on Pascal 13. So I think, just looking at it, we have the second highest possible expression that they have. So we've got to have good odds that we're in the right answer. Oh well, I'll see you guys next time for question number 14, which hopefully is a little more clear.